we're going to look at graphing a polar equation that ends up with a limacon. It's kind of French. That C has the little guy underneath it. So a few things to notice about the equations. First, that if I have a cosine, that's a horizontal orientation. So that means it will, the bigger part of it will be on the right if it's positive, left if it's negative. If we have a sine, that's a vertical orientation. So that means that the bigger piece of it will be above the x-axis if it's positive and below the x-axis if it's negative. The values of A and B are important, and they tell us the shape of our limacon. You can see the different shapes there. So when you're choosing your tool in ALEKS, if you have a limacon with a loop, you're going to choose the guy with the loop. For all the others, you're going to choose the guy with the dimple because you can move that little dimple to the point where it needs to be. Okay? So to graph a limacon, we determine the shape by comparing A and B. Then we're going to determine the orientation. So remember, if it's cosine, it's horizontal. Positive, the bigger part is going to be on the right. Negative, the bigger part is going to be on the left. Sine is vertical. If it's positive, the larger part is going to be above the x-axis. If it's negative, below the x-axis. So in ALEKS, I'll choose the correct tool based on the values of A and B. So it'll be one of those two guys. Then I'll choose the orientation, and you'll see in ALEKS, it's not a tool, but you'll see when you do it how it says, okay, which direction do we need to go? And then we're going to use these 4 points, 0, pi over 2, pi, and 3 pi over 2 to plot our points. So here, first, we're going to figure out the shape by comparing A and B. And since A is bigger than B, but smaller than 2 times B, we have a dimpled limacon. Now to look at the orientation, we have a positive sign. So that means the bigger part of our shape is going to be above the x-axis. So then we start to look at our points. At 0, our ordered pair is 1, 0. Then I'm going to plug in the y value, right, for the sign. And my ordered pair is 5, 0. And then I'm going to plot that point. Next, I'm going to do the same thing for pi over 2. Get the ordered pair, plug in the y value, get my r theta, and plot it. Then for 3 pi over 2, my ordered pair, plug in my sine value, and plot the point. And then lastly for 3 pi over 2. And then in ALEKS, again, you can see that the bigger part of my shape is above the x-axis, like we said. And then in ALEKS, you will end up with this. Okay? For this one, notice first we're going to look at A and B and find the shape. A is bigger than 2B, so this is a convex limacon. It's a positive cosine, so the orientation is the bigger part of it's going to be on the right. And then I do the same thing. Look at 0, pi over 2, pi, and 3 pi over 2. Find my ordered pairs, plug in my cosine values. So my first r theta, or my first polar point is 8, 0. Then we have 6 pi over 2, 4 pi, and 6, 3 pi over 2. And then that's what it would look like in ALEKS. Here, again, we're going to compare A and B. And here A is less than B, so we have a limacon with a loop. Our orientation, since it's a negative sign, the bigger part of our picture is going to be down. Then we do the same thing. Our 4 points, find the ordered pairs, plug in our sine values, and come up with our points, which are 3, 0, negative 2 pi over 2. So take a second to realize where that is. Remember that negative means we go in the opposite direction. 3 pi, and 8, 3 pi over 2. So that negative 2 there is what's going to form the loop. Lastly, comparing A and B, A is equal to B, so we have a cardioid, which is kind of like an egg. It's just kind of flat on the bottom. Our orientation, we have a negative cosine, so the bigger part of it's going to be open to the left. Then we do the same thing with our 4 points, the ordered pairs, plug in our cosine values. We get 0, 0, 4 pi over 2, 8 pi, and 4, 3 pi over 2. And that's what it would look like in ALEKS.